Alright, and welcome to Cross Sections Level 4. Now in our very first example, we are given the square below represents the horizontal cross section of a pyramid, and I really want you to circle that word pyramid because we know that in this case, the horizontal cross section is not exactly the base, and we have to be very, very careful. And has dimensions 2/3 the lengths of the base, okay, so that's very important. What would the total surface area of the pyramid be if the slant height was 22 inches? Okay, let's kind of start this off by first writing out our formula for this equation. So the total surface area of a pyramid is pretty straightforward. It's going to be this. 1/2 times the perimeter of the base times the slant height plus the area of the base. And kind of the distinction here is it's only the area of the base because a pyramid only has one base, as opposed to a prism which has two bases. That's why in our previous video we had 2b, here it's 1b. Okay, so let's go from left to right, and the only tricky part about this is going to be to find the perimeter because we're not going to be using this number 9 right here, okay? So how can we do this? Let's see. 9 is 2/3 the length of the base. Well, this is going to be a little bit weird, but what you actually have to do is you have to take 9, and we're going to actually divide that by 2/3. Now you might be asking yourself, why would you do that? Well, if we were to do 9 times 2/3, we'd actually be making our number smaller since 2/3 is less than 1. Here we know that this length is 2/3 the length of the base. We're imagining, essentially, we're saying, hey, here's a pyramid, and it's going through these points, it's going past them, and our base is down here a little bit further and a little bit larger. So we're saying that this little square that we see, it's not the largest thing. So if you want to make that number larger, you don't multiply by 2/3, you divide by 2/3. Now, I know fractions are some of our weaker points, so I'm going to change 9 into 9/1, but what's the rule with dividing by a fraction? Well, you multiply by its reciprocal. The reciprocal of 2/3 is 3/2. So all it means is that you take the fraction and you flip it. Well, 9 times 3 is going to be 27/2. And so essentially all we're saying is that this 9 is not the base length. The base length will actually be 27/2, which is really and truly 13.5. Okay, now that we have that number, we can actually finish out this problem fairly easy. We'll say our surface area is equal to 1/2 times, and remember for the perimeter, you're just adding up these four sides. So what is 13.5 times 4? Well, 13.5 times 4. I'd probably encourage you to grab a calculator right here to do this. I'll grab my own just so I don't make a mistake. My guess, if I had to make one, would be 54. Let's just find out. Let's see. 13.5 times 4. Oh yeah, that'll give us 54. Hey, perks of being a math teacher, right? Times. Now it's asking us to find the slant height. Well, if you look back in the problem, we see that the slant height here was 22 inches. So plug in 22 plus, and here we actually need the area of our base. So how do we get the area of our base? Well, remember, it's a square, and one of the sides is 13.5. So remember, to find the area of a square, you simply do area of a square is equal to this side, 13.5, squared. And while that might seem a little bit redundant, so let's see, what's 13.5 times 13.5? That would give us 182.25, and I really had to squeeze that in there. Okay, so just a couple of calculations and we'll have this finished. In your calculator, what I would do is this. We know that 1/2 is the same as 0.5 times 54 times 22, and that will give us 594 plus this 182.25. Let me really block that off so you don't get confused. And all we have to do is add those two numbers. So let's see, 594 plus 182.25. And we wind up getting this answer, 776.25. Remember, in this case, it will be inches squared because this is surface area. All right, pretty easy. Let's go ahead and move on to our next example. The triangle below represents the vertical cross-section of a cone. So here we are. We're in our very second example, and we know that this is probably going to be the most important statement right here. So we're given this triangle. It's the vertical cross-section of a cone. If you want to immediately be able to visualize this, I would draw a circle through BC because it's telling us that this right here, let's scratch that out, let's write BC. Once again, I'm using a different picture here. BC is the diameter, and so our cone would look like this. And it's also telling us that our cone has a height of 8 inches. So here's what I would encourage you to do. I would encourage you to draw a dotted line going straight down. Well, let's write an A right there. So let's just kind of review this one more time. We're saying, all right, we have a vertical cross-section of a cone. We want to find the total surface area when given the height of the cone is 8 inches, and BC is our diameter. Okay, so let's start with the total surface area of a cone. What's that formula look like? Well, that's going to be S equals pi r L plus pi r squared. Okay, now when we look at that and we want to find the total surface area, we're going to go through and fill in everything we know right off the bat. So we know pi. We know our radius. Let me ask you guys, if our diameter is 12, what's the radius? Well, the radius is always half, so our radius must equal 6. Now, the one thing we don't know is we don't know this length, the slant height. So I'll leave an open parenthesis right there. We'll come back to that. Is equal to plus pi r squared, where we know that our radius is still going to be 6. My apologies. Once again, that's a plus sign, not an equal sign. So the question becomes, how can we find this slant height? Well, if you notice, this height right here and this radius actually create a right triangle. So let me draw a right triangle right here, where our base is half of 12, that's going to be that 6, and our height is going to be 8, and we want to find this length right there, the slant height. So how do we do this? Well, we're going to use the Pythagorean Theorem. A squared plus B squared is equal to C squared. And guys, this slant height is really the only way that they can kind of make this tricky. So let's talk about our A term. We know that A and B are just our bases, the legs of the triangle. So we can write 8 squared plus 6 squared, and once again, having some stylus issues, I do apologize, is equal to C squared. Okay, so ask yourself, what is 8 squared? Well, that's 8 times 8, which would be 64, plus, and what is 6 squared? Well, that's going to be 36, is equal to C squared. Okay, and what is 64 plus 36? Well, that's going to be 100, is equal to C squared. And here's where a lot of people make mistakes. They think that the 100 is actually the slant height. Don't forget, you always have to take the square root of that number, and we know that the square root of 100 will actually be 10. So, how long is our slant height? It's going to be 10, and we can now plug that in and now finish out this equation. Now I'm going to finish this out first in terms of pi, and then we'll get our approximate decimal. So what is 6 times 10? Well, we would have 60 pi plus, and right here, what is 6 squared? Well, that would be 36 pi. Okay, since we have 60 pi plus 36 pi, and those are like terms, we can combine them and ask yourself, what is 60 plus 36? Well, that's going to give us 96 pi. And lastly, all we have to do is multiply 96 pi, or 96 by pi, and you're going to have to use your calculator for this. So, let's go here. We can type in 96 times. Just turn your calculator sideways, multiply by the pi button, and we should get approximately 301.59, rounded to the nearest 100th. And this will be in inches squared. Remember, whenever we have a surface area, our units will always be in inches squared. Alright, well, I hope that these videos have helped you out. If you need any help, please email me, whastings@dallasisd.org. I'd love to help you out with these. Alright, take care, guys.